Hello and welcome to this Morpheus Tech Brief. I'm Martez Reed, Director of Technical Marketing with Morpheus Data. In this Tech Brief, we're going to walk through integrating the Morpheus platform with GitHub Actions. So the first thing is to understand what GitHub Actions is. For those that aren't familiar, GitHub Actions is a hosted CI/CD platform that integrates with GitHub, likely the most popular, uh, widely available Git repository that is hosted online. So certainly for those that are familiar with GitHub, built into that capability is a solution known as GitHub Actions, which is commonly leveraged for, as I said, the CI/CD pipeline aspect of software development. So as an example, on this particular slide, we have a YAML file, which is the definition for the GitHub Actions workflow automation. So in this case, there's a number of different items. We're going to walk through some of these various aspects to better understand how they tie together. Certainly the focus is not to delve deep into the specific nuances of GitHub Actions itself, but do want to highlight how the Morpheus platform could be tied in and integrated into a CI/CD pipeline that is built in GitHub Actions itself. So as I said, we're going to delve a little bit deeper into some of the aspects of even what we see here. So one of the things we want to do is take a bit of a step back when we talk about CI/CD pipelines. We're talking about continuous integration and continuous delivery or continuous deployment pipelines. Really what it means is leveraging automation to be able to facilitate the testing as well as automated deployment of software, whether that be oftentimes infrastructure as code or the more traditional software that is utilized to power platforms like ServiceNow or Workday, insert any other software solution of choice. Typically, a CI/CD pipeline is going to be utilized to provide consistency, repeatability, and testability of the software as it goes through the various phases of the software development lifecycle. So to keep it simple, in the example we're going to walk through, have really focused on 4 different phases or stages of our pipeline in particular. This is really more representative of many of the phases that you might see in a standard CI/CD pipeline, but certainly is not all inclusive, all the potential steps that could be included in such a pipeline. So as an example, in this case, we're going to deploy a HTML web page. Common thing that would be done in one of the first stages or phases would be something like unit testing. So this is going to check for syntax as well as code quality as part of the initial process. In here, you would likely also get, after the unit test, a build depending upon the language of choice. So whether it be something like Golang or Java, you're going to get a build stage or build phase to actually build the artifact to then be oftentimes pushed up to an artifact registry or repository. So as I said, we're going to truncate the process to really reduce the focus to Morpheus integrating with the CI/CD pipeline via GitHub Actions. So in this case, after the code has been checked and validated, we're going to then provision. In this case, I want to deploy an Ubuntu virtual machine to then test and validate the code that has been deployed for acceptance purposes. So oftentimes you have initial capability or testing functionality known as unit testing, which is where I'm testing the actual the unit aspects of the code. So sometimes there are dedicated tools for testing a given language that you would then run. What we want to do is leverage the Morpheus platform to build out an actual working environment to then be able to run our acceptance test against the running environment. So in this case, it would be deploy the particular web page to a Ubuntu virtual machine, and then as part of that, run some basic tests from a functional standpoint to be able to determine, does the web page actually load? Are all the things in place to actually successfully run the website, as an example. And then finally, we want to destroy or tear down this particular instance once we're done and the test have successfully passed. So now that we've got a high-level overview of what we're looking to accomplish, let's delve into some of the code. In this particular case, I'm just deploying a very generic Nginx web page for understanding purposes. certainly not focused on the unit testing or some of the lower level aspects of how to get the code out into the given environment, but certainly walk through some of those things as we go through. So we talked about the GitHub Actions pipeline. So in this case, an initial decision needed to be made of how was I going to be able to integrate with the Morpheus platform via GitHub Actions. Typically with GitHub Actions, you're going to leverage containers or native GitHub Actions or third-party GitHub Actions as they refer to as well. So what that is that there's been a action or a task type or a piece of code, however you may want to refer to it as, that does a particular thing. So as an example, one of the first ones we commonly will see in all GitHub Actions is checkout. What the checkout action is going to do is going to actually pull down the code that is in the GitHub repository and then utilize that for later purposes within the actual job itself. So as I said, the actions are typically going to be tied to a singular purpose. Some may have different options that can be exposed to slightly change the purpose or the action for that particular GitHub action itself. So we needed to decide how we were going to interact with Morpheus, as I said. And so in this case, I decided to utilize and leverage the Morpheus CLI. Morpheus REST API can be utilized as well as part of integrating with GitHub Actions. But in this case, the CLI has already been containerized for us, and I wanted to take advantage of that existing capability to reduce the quote unquote glue code that I had to write for this particular example. Certainly, if there is additional complexity, oftentimes you may want to leverage a Python script or a bash script, something that provides a little more flexibility to be able to iterate on the process as you desire. So now that we've checked out the code, so it's going to check out the code. In this case, I'm using the Morpheus CLI container. What I'm going to do is I'm going to add the remote endpoint for the Morpheus platform. So in this case, I am leveraging the API of the Morpheus platform that I want to reach. And I'm passing it a few flags in particular, based upon the fact that I do want this to be a automated process and not prompt me for various inputs that the Morpheus CLI would normally prompt for. So I'm passing certain flags, things like that I want to use this particular remote endpoint. Once we've added it, I also want to ensure that it is secure, as well as a number of different other options that I'm passing. In this case, the n-n is don't prompt me for it. So want to use it in a non-interactive fashion. And once I've added the remote endpoint from Morpheus standpoint, I want to log in utilizing an API token. So we've seen two references to secrets in this particular GitHub Actions workflow. So GitHub Actions supports being able to define secrets or essentially sensitive data that I may want to pass into the GitHub Actions workflow. The other benefit could be is I could specify, as an example, maybe I don't want the API URL to be a secret. I could have specified just a plain environment variable in which I can then reference it later within the actual automation and the script. So I'm going to log in. So we've got the remote endpoint added. We're logging in to our Morpheus platform. And then now what I want to do is I want to deploy an instance. In this case, I want to deploy the Ubuntu instance that is going to be utilized to actually host our website. So I will open up a new tab so that we can take a look at the payload itself. So I'd set it to go with a YAML payload. By default, the Morpheus platform is going to allow the ability to be able to output from the command line to JSON. So for those that aren't familiar, the CLI does have a number of flags that can be utilized to be able to generate such a payload. Typically, what I'll utilize is Morpheus instances add, and then I'll do -d for dry run, and then -j to generate the JSON output that would then be utilized as the payload for that particular instantiation of the instance. In this case, I wanted YAML for readability. So I essentially just went to a JSON to YAML converter and converted the JSON to YAML for readability purposes. And then I'm able to pass that YAML payload via the CLI as well as a JSON payload. So in this case, I specified most of the common information that you would expect from a Morpheus payload perspective, things like the service plan, the cloud, the instance context, the layout, additional configuration options as well, to be able to define the instance that I want to provision or deploy from a Morpheus standpoint. So I've got my test.yaml payload. And so what's going to happen is I'm going to instantiate this particular instance in the Morpheus platform. And so I'm going to reference that test.yaml payload. And then what I'm actually doing is outputting the response via JSON. The reason I'm doing that is because I want to grab information about the instance to be able to track the process. So in this case, what I want to grab from the response payload is the ID of the instance, which will allow me to then run subsequent commands to do things like pull the status of the instance, as well as to finally destroy the instance once my testing and validation has been completed. So we've gotten through the initial Morpheus setup and we've provisioned the instance itself. Now what we want to do, as I said, I want to grab the instance ID. So in this case, I am using a third-party GitHub action to parse the JSON file that we just laid down. And so if you decide, you know what, I don't want to use a third-party tool, this could be a situation or a scenario where you decide, you know what, I'm going to write a Python script or I'm going to use JQ to be able to parse that information appropriately to be able to pull back the instance ID. In this case, I went for simplicity, certainly a number of options that can be utilized or leveraged to be able to facilitate that. Yep, so if there's any questions, certainly feel free to post them in the Q&A and I can answer them as I go through. So now that we've parsed the JSON payload to grab the instance ID, in the case of the JSON payload, where the ID is at is it's under instance and then ID, which is why we have the instance.id essentially becomes a dot notation reference to the instance ID. So the next thing we want to do after we've parsed that ID from the JSON payload that we generated when we ran the Morpheus instances add command is we want to actually set that as a GitHub action output or the ability to be able to reference that in subsequent steps of our GitHub Actions pipeline. So in this case, we are grabbing the information that was supplied from the parse instance ID step, which is what we have here. So the ID of this particular step is parse underscore instance underscore ID. And the outputs that we want to leverage, and then the value of the particular output. So in this case, we are going to set that to instance ID, camel case, so that way we can be able to reference that in a later or subsequent step. In this case, the next step is going to be simply outputting that instance ID, so that way we can just ensure that the instance ID has been properly set for ease of use to be able to see, okay, did I properly parse the JSON payload as I was going through testing and evaluation? In this case, I've got that there just in for some additional debugging or logging. And then now that the instance has been provisioned, one of the things that we need to do is that we need to wait for the instance to be ready. So in this case, what I'm going to do is I'm going to leverage Morpheus CLI to run Morpheus instances Git. And one of the things that we see here is that we've referenced the ID, instance ID, via that payload. So we had the steps, we had the set instance ID, and then we utilized the inputs instance ID to be able to grab that information. And then we ran -- refresh 30. So in this case, this is really the key capability that we leverage from the Morpheus CLI. Certainly it can be done via the REST API, but what it's going to do is it's going to poll for the status of this instance. So when you go to provision or deploy an instance in the Morpheus platform, you go through the various phases of a workload's lifecycle. And so when I go to provision this particular instance, it's going to be in provisioning for quite some time. So in this case, it's about 2 or 3 minutes. It's an AWS instance, spins up pretty quick, but I do still need to wait for the instance to be ready. And then I need to leverage the automation in the Morpheus platform, in this case, an Ansible playbook that is running to be able to facilitate the installation of Nginx and all the things that come with that. So I want to wait for the instance to reach a ready status. And the 30 is going to be poll the instance status every 30 seconds until it is ready. There are some additional flags that could be added that provide a more granular level of capability to determine the status or statuses that you might decide you want to end the polling on. So once this is done, it's going to be able to allow me to interact with the system. Certainly another thing that can be done here is adding another step to be able to fetch the current status of the instance even after it's done polling. So as an example, there may be a reason that the instance was deployed, but the instance failed. I may want to grab that information and add some additional logic to say, if the instance failed, maybe perform another retry, maybe tear it down, spin it back up. I may also decide that I want to do something in addition to that. Maybe it's send a message that pipeline failed, whatever it might be, that allows that flexibility to adjust based upon the situation and the desired outcome, particularly as it relates to error handling within the pipeline itself. And then once we have the instance is ready to go, what I want to do is I want to grab the IP address of this particular instance. So there's a couple of ways that this could be done based upon the configuration. In this case, I am grabbing the first IP for this instance. That is the publicly addressable IP that I want to be able to fetch and then test against from this standpoint of my public website. Certainly, there's a number of other ways that you might want to grab that information. Maybe it's the second interface, or maybe it's a different mechanism that you might want to grab that from the payload that is returned via the Morpheus platform. Certainly all possible, but in this particular case, I'm just grabbing the IP of the connection information. So I'm running the Morpheus instances git command once again, and I want to output that to an instance ID. And so at that point, I'm going to, so we use the variable to grab the instance ID, and I'm dumping the output for the IP address to the JSON payload. So the question is going to be, well, didn't I already dump the payload to the system to already have? So yes, I did. I did already dump a payload when I did the initial output. So when I initially added the instance, I outputted that to output.json. The difference is the IP address was not established yet for this particular instance. So the payload, in this case of output.json, includes the instance ID, which is what I want, but it does not include the IP address on the network interface that's going to allow me to be able to test against this particular instance. So that's the reason for running that very similar command once again, is to grab that IP address. So once again, if you decided you want to do this via a Python script, a bash script, certainly you could keep it all very much self-contained and iterate through and run through the various steps that we see here to reduce certainly the number of steps that we see here. But in this case, walking through the process of what this would look like. And so now that we've dumped it to our IP.json file, we're going to run the same sort of operation that we ran to get the instance ID. We're going to leverage that third-party GitHub action, and we're going to parse instance.connectioninfo. In this case, I want to grab the first entry. For this particular instance, there's only one network interface. That's all that's going to show up anyways, but I do need to specify that explicitly, as I want to grab the IP fields for the connection info. In this case, that's going to return the IP address that I want for this particular instance. And then we're going to go to the similar process as we did to be able to define that instance IP and set it as an output for this particular resource. And then we're going to leverage the echo command to just output that file. And so once we get further down, running some very generic test automation, as I said, this is not about how to run test automation or how to build a website, any of those things. Really, it's focused on how the Morpheus platform could be tied into it. And so I've got, as I said, I got some basic test automation. Really, I'm just going through the process of sleeping for 60 seconds, wait for the website to be fully loaded. And then I'm going to just run a curl command against the website just to determine if the website is up and running and then see the output. Certainly there's far greater tools from a testing harness standpoint that can be utilized to validate the functionality of a website or a web application. As I said, that's not the focus of this, but it's to show the infrastructure being spun up and then quickly spun down. And so then once the testing of the web page is complete, we're going to run a Morpheus instances remove. Once again, we're going to leverage the instance ID that we set earlier in the pipeline. In this case, I'm going to leverage the -y flag to ensure that we're actually destroying the instance without being prompted for any information, such as whether I want to remove volumes or things of that nature. So we walked through the GitHub Actions pipeline for leveraging this. So let's take a look at what a run looked like from a GitHub Actions standpoint. So let's say we got the various different steps that we walked through in the YAML file. So we added the remote, which is that command. So in this case, added demo, added remote demo, status of ready. So now Morpheus platform is tied into the CLI. It's ready to go. We're going to log in. So in this case, logged in as myself. So that was successful. Then we're going to deploy the instance. So this is that run Morpheus instances add command. And then we're passing the YAML payload as part of the instantiation of this resource. So a couple of things I do want to note here with the instance. In this particular environment, there is a naming policy in place in which is going to ensure the uniqueness of names for the instances deployed. And so in the test.yaml payload, there is not a name that is specified for the instance. So that is going to ensure the uniqueness of the instances names as they're deployed as part of this process. Certainly, there's a couple of ways you could do something that's a little bit different. You may decide you want to pass the name as a command line flag and then utilize some unique variable that is available in the GitHub Actions, maybe like the date or maybe the build ID, to tack on to the particular instance to ensure uniqueness. The other thing you might decide you want to do is you also want to customize the deployment based upon some other information as part of the GitHub Actions pipeline. In the case of the CLI, you could pass those additional values as command line parameters that are going to be unique or different based upon the information in the job, or you may decide you want to go through the process of customizing the actual YAML payload to include some additional variable substitution as part of the process. Certainly a number of ways it could be done. You could go that route, or you could decide you want to, once again, write some glue code to be able to stitch it together via something like Python. So there's a thing to note there. So we're going to parse the instance ID. And so that was running the GitHub action from the third party. I'm going to set the instance ID. In this case, we're setting the instance ID. So we see that is 84625 is the ID of this particular instance. We're going to output the instance ID just to ensure that we're actually generating the output. So then we're going to wait for the instance. And so what we see here is the Morpheus CLI refreshing or polling for the status of the instance every 30 seconds. So we see instance details. We see instance details again. We see instance details again. So we see that it says refreshing in 30 seconds. So that's the polling mechanism that's been put in place to allow us to be able to wait for the instance to be ready or to reach that ready status. So as we see here, it's still currently in the provisioning status on one of the previous polls or iterations to determine the status of the instance. So let's jump down. And so we see that the status finally reached the running phase. And so that allows us to then be able to have a running instance that is ready to go, is available. In this particular case, I'm leveraging a Ansible playbook to automate the installation of Nginx that's included as part of the provisioning of this instance. So that's going to walk through the whole process of spinning up the instance, getting it prepped for the environment, getting it ready to go to actually perform the testing and evaluation. So in this case, we see that we have the IP address that is available. So that's the information that we need to grab. So once again, we're going to run that Morpheus instances get command to be able to generate the payload to be able to fetch that information from. So once again, very similar to what we did with the instance ID. We're going to run those various different operations. We're going to specify that we want the instance IP to be set to the IP address that we fetched back from the payload. And then we're going to spit it out just for the visibility. And then we're going to run our test suite, quote unquote, which is, as I said, very, very basic capability, but does show the process of the Morpheus platform to be able to tie into the GitHub action pipeline and be able to be leveraged as a platform to spin up and spin down environments very quickly for testing purposes. So in this case, we ran the curl command against this particular instance, specified that IP address. And in this case, as I said, not focused on the HTML or any of the CSS or JavaScript, but we are able to pull back the basic Nginx web page for this particular instance. So we went through the whole process of provisioning the instance, in this case in AWS. We grabbed the appropriate information, we waited for it to be complete, and then we tested that the web page was accessible. Certainly you could perform some additional testing and automation to validate the context and the capability of the website or web page itself. So now that we've tested the web page, everything is ready to go. We want to destroy the instance because the test was successful. Another thing we could do from an orchestration perspective is maybe we might decide we want to add a flag as part of our pipeline that allows somebody to be able to specify, as an example, they want to not destroy the instance after the testing has been performed for evaluation purposes. Maybe you decide you want to utilize environment as part of the flag. So maybe for feature branches, you might decide, you know what, spin up the environment, tear it down very quickly. Maybe for a user acceptance testing environment, you might utilize that as the denoter or delimiter to specify for this environment, do not tear down the instance after the initial automated tests have been run, but keep it running until at which point somebody has been able to validate the environment. But in this case, I'm spinning it up and tearing it right down after the testing has been completed successfully. So in this case, as I said, we're grabbing that instance ID and then utilizing that to remove the instance as part of the process. So as I said, there's that naming policy in place in this particular environment that is being leveraged to ensure the uniqueness of this particular deployment in the Morpheus platform. So we walked through integrating with a CI/CD pipeline. Certainly, one of the things we talked about in particular is the focus on GitHub Actions, but these same sort of steps and integrations or tie-ins could be done, whether it's GitHub Actions or GitLab, or insert your CI/CD pipeline of choice as part of an integrated provisioning process. So as I said, would have been a unit testing stage or phase, would have been potentially some build phases or pushing artifacts to something like Artifactory. Then we went to provision the environment. We utilized the YAML payload to define what our instance looked like. We ran through some very basic acceptance testing to ensure that the web page was up and functional. And then we destroyed the instance once that particular test was completed to ensure that the environment was clean and pristine after our CI/CD pipeline ran. So that walks through integrating with GitHub Actions from a CI/CD pipeline perspective. One of the other things that GitHub Actions does offer is what they term as GitHub Actions workflows. For all intents and purposes, it's the exact same thing we just took a look at. But one of the things that's commonly done or leveraged more and more in IT environments is leveraging CI/CD pipelines to run various automation tasks. So as an example, as a former cloud engineer, one of the things I commonly had was a Python script that was in a GitHub repository that was ran every week or every night to clean up unattached EBS volumes or to clean up orphaned AMIs or AMIs that have reached their expiration date, so to speak, or various other operational tasks in the environment. So leverage the capability to be able to host them in the Git repository, and then leverage the functionality of GitHub Actions workflows as part of that process. One of the challenges that I commonly ran into with leveraging something like GitHub Actions was the lack of, shall I say, self-service capability. with the actual execution of the workflows. That was one of the things that GitHub did add with their ability to be able to dispatch or run a workflow on demand in addition to running it on a schedule. Certainly that offers that flexibility and capability. But to a greater extent, what I often also wanted to do was extend that capability out to individuals that were not on my team and that didn't have direct access to the GitHub repository. I didn't really want to give direct access to the GitHub repository to be able to run those particular operations and tasks. So it would have been great to have a platform like Morpheus to be able to front in that, but still take advantage of the capability within the GitHub action as part of the process. So I'm going to walk through an example of how that integration might look. In this case, I'm leveraging the GitHub REST API and a Python script to stitch those components together, and then certainly walking through layering in the Morpheus components to expose that as a self-service catalog item. So let's take a look at what that would look like from a Morpheus component perspective. So what I want is the catalog item. So certainly we're going to have to create the catalog item. I'm going to leverage or rely on an operational workflow to be able to execute the automation via a catalog item. And in the case of GitHub Actions, I've specified that I want an additional input or parameter. In this case, it's going to be message. It'll just output the message. And then another required parameter or input to GitHub Actions is the branch. I could have decided that I just want to run on main or master and then did not expose this to the Morpheus platform, but I did want to allow some flexibility in this particular scenario. As you look at things like test environments or you want to test new iterations or versions of the particular automation that I might want to test on a dedicated branch. And then finally, it's going to be backed by a Python task. And then often you would leverage a Git integration to be able to reference that particular Python task. So let's take a look at what that would look like from a capability standpoint. So let's actually take a look at the workflow itself from a GitHub Actions perspective. So very basic workflow that we have here. And so one of the things that we have is, so in the case of GitHub Actions on is going to be, when do I want this particular workflow to run? And in this case, it's going to be workflow dispatch, which means that I want to be able to run it essentially on demand and not necessarily tied to the pushing of code as part of my pipeline automation. So I have inputs. We saw the message. So I want to output the message. That's a required input. In this case, GitHub Actions input. And then as part of the actual job, I want to simply print that message out to standard out. And then I added in a sleep mechanism to provide what would be more akin to a real life workflow that would run for some time and be executing in the environment, but need to be polled as part of a given process. So let's take a look at our GitHub Actions integration in the Morpheus platform. And so we'll work from the catalog item back. So in this case, I have a GitHub Actions workflow catalog item. You have the branch, in this case, it's main, and I have the message field, which allows me to be able to input information into the particular message. So let's add that in. And let's click order now. So away it's going to go, starting to orchestrate through that process. So let's take a look at a previous execution. So there's a number of things that we have going on here. So the Python script is going to run. And so it's going to do things like poll for the status of this particular workflow execution. But let's take a look back on the GitHub Actions side to see what's happening. So we can see in this case that the GitHub action is actually running. In this case, it's the dispatch. And so it's right now it's sleeping, which is essentially waiting on the 120 seconds to elapse. But one of the things that we did see was the input that we specified for the GitHub Actions has been populated by the input from a Morpheus standpoint that we provided, which was Morpheus tech brief. So certainly in a real life example, you likely have potentially various inputs that are then utilized in a more meaningful fashion. But it certainly does show the way in which to tie that into the Morpheus platform. So while that's running, let's take a look at the underlying components of our catalog item. So let's take a look at automation. Let's go to workflows. So in this case, there is the GitHub Actions runner workflow. This is an operational workflow that is backed by a Python script that is utilized to trigger the GitHub Actions workflow. And then there are two inputs that are defined for this particular operational workflow, which we saw exposed via the catalog item that we had. So we see that the GitHub Actions branch, which we saw was set to main by default. And then we have the GitHub Actions text or message, which is what we saw when we generated the actual output from the GitHub action. We saw that it said Morpheus tech brief. So I'll align to that. Let's take a quick look at the trigger GitHub Actions workflow Python script. So let's take a look at that. So I'm not going to delve extremely deep into the actual Python code itself, but more so talk through many of the major components and how it's being tied together. So there's a couple of things that we're leveraging from a functional perspective. There is the GitHub Python library, which is PyGitHub, that is being utilized or leveraged to talk to the GitHub API to facilitate the various operations. We're leveraging the Morpheus-Cypher library for referencing the GitHub Actions or the GitHub token for authenticating to the GitHub as API and storing that in Morpheus-Cypher. So we're going to reference that secure storage. And then finally, we're going to leverage the request library for making additional API calls that we might need. So let's jump down to the major component. So as I said, we're grabbing the GitHub token via Cypher. We're going to get the repository. So in this case, this is the PyGitHub library. We're going to get the repository. In this case, it's Martez R, GitHub Actions Tech Brief is the repository where the workflow exists. The name of the workflow is dispatch.yml. So that's the file that exists in the GitHub repository itself. That's the workflow that we want to run. So in this case, we're going to get that workflow, and then we're going to specify the data or the input to the actual GitHub action workflow itself. So we saw on our GitHub action that there was a field for specifying the message that we wanted to output. So in this case, I am referencing the custom option or the input from the Morpheus operational workflow that was tied to the message, or as we saw it in the Morpheus platform, it was the GitHub Actions text. So that's what we're going to reference to then pass to the GitHub action itself as part of the API call. Then we're going to get the branch. And in this case, we've got the additional input that we saw, which was branch. As I said, this could have been specified as, I just want to use main or master for this and hard code that and not expose that. But as I said, there's some value in exposing that for testing purposes to where I might want to iterate on a feature branch as part of my testing and then be able to leverage that new version when I push it into main or master. So certainly some flexibility. That is certainly a preference as to how you want to expose that. And then I'm going to trigger the workflow. So in this case, we're passing the workflow definition, we're passing the ref, the get ref. In this case, it's main. And then the data itself. So this is the payload that's being passed into the GitHub action to provide the input or instantiate this particular deployment. Then at which point, after it's been triggered, what I want to do is I want to poll the workflow execution, which is what we saw why there was the sleep in there to be more representative of a real life use case, as opposed to the workflow is going to be triggered and then it instantly completes because it's just simply going to output that data or the message that we specified. So in this case, it's going to be some custom coding. Certainly focuses not on my capability to be able to author Python, but to really walk through what that would look like from an overall polling standpoint. Similar to as we saw when we provisioned the Morpheus instance, there was a need to wait or to poll for a particular event before we proceeded as part of the process. So in this case, I'm going to pull the execution. Before we take a look at that, I do need a status. So that's what we saw with triggering the workflow. So we triggered the workflow, which means we created the dispatch, and then we wanted to grab the current status or print the status of the particular instance. So in this case, while the status is in progress or queued, we're going to iterate through the runs from a GitHub Actions perspective that are tied to this particular workflow. So in this case, if the run ID and the ID that we specified match, we're going to then start the iteration of this process. So there's some additional logic that was added here, in particular for GitHub Actions, to ascertain the current execution and tie the two together. So what I mean by that is, unfortunately, GitHub Actions, when you trigger a execution or a workflow, it does not return the ID of that workflow run or execution, which is commonly what you would leverage to track the execution of that ID or that run. So in this case, the script is written in a very best effort fashion, simply because the GitHub API does not expose that information as one might expect. So in this case, you're more so relying upon the quick execution or dispatch, and then grabbing the most recent execution as part of the process. So certainly in this case, it is possible to run into some race conditions until GitHub adds a ID response or an ID field in the initial creation of the dispatch response. So in this case, I'm checking the run status to determine if it has reached a status other than in progress or queued, at which point I'm going to keep iterating through that process and then wait for that status to change, in this case, for it to be a success or to be completed. And in this case, there's some additional capability that's added, as I wanted to grab the log information that we would see during the execution of the GitHub Actions to be able to reference that. So in the case of GitHub Actions, it's actually a zip file. So there's some pulling down of the zip file and iterating through that process. But that walks through the hook or integration into GitHub Actions. In this case, I can leverage the existing automation or workflows in GitHub Actions, but also afford me the capability to be able to expose those in a self-service fashion via the Morpheus platform, or I could make the decision that I want to leverage the Morpheus platform's scheduling capability to schedule the execution of those workflows, as opposed to moving those into GitHub Actions itself. I found that that pattern useful, in that if you have a number of GitHub repositories with various different workflows, it can be quite challenging to get an overall view of when those workflows are being executed without going into each of the individual repositories to determine that information and make sure that, certainly unless you have a better tracking system in which you've documented that in a central location. So certainly a benefit of tying it into the Morpheus platform from a scheduling perspective. So that walks through various aspects of integration with GitHub Actions from a Morpheus standpoint. One of the ones that I didn't touch on that could also be very interesting is, similar to how we talked about the integration with the Morpheus and the CI/CD pipeline, GitHub Actions supports the concept known as self-hosted runners. And so what that means is the ability to be able to execute the automation on a custom or a self-managed endpoint that you might have in your environment that is going to be there for either security purposes or just overall connectivity purposes, to be able to allow the GitHub Actions to talk to, let's say, either Morpheus. If it is not publicly accessible, you could leverage a self-hosted runner to facilitate that communication, or you could also leverage it as part of an overall integration into the environment. And so by leveraging the Morpheus platform to provision and essentially manage those self-hosted runners, you'd have the ability to be able to quickly spin up and add new runners as part of a process. And so let's take a look at one of the workflows to see what that looks like. So in this case, we see a runs on for this particular job. So I could specify the self-hosted functionality to run the GitHub action workflow on a runner, as they refer to them as, essentially a box, a VM, a container that I manage that I want the GitHub action to run on to execute the various steps in my workflow. So it's going to provide me the ability to be able, as I said, handle security considerations, as well as just have greater control over what is available on the runners if I decide that I wanted to add something additional from a custom tooling perspective as part of that process. So that would offer me the ability to be able to do potentially some very interesting things from a management standpoint, spin them up, tear them down. I could also hook into Morpheus platform, potentially from a REST API standpoint, to leverage things like scaling to spin up workers or spin up runners in a more dynamic fashion. But that has covered this Morpheus tech brief on integrating the Morpheus platform with GitHub Actions. Certainly appreciate the time and everyone joining. Have a good day.